Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we are going to have another Q&A video. And today's topic is going to be very short, all right? And it's about correlating permeability with porosity with the use of Kozeny-Carmen equation, all right? So it's one of the most popular correlations that connect the permeability and the porosity, right? This equation is formulated based on packs of equal diameter spheres as shown by this equation, right? So permeability equals to porosity to the power of 3, and then dP is particle diameter in meter squared, and divided by 72 multiplied by tau, which is the tuosity, and multiplied by 1 minus porosity in fraction, and then you square them up. All right, and then you need to calculate the tortuosity as well. And the tortuosity is the porosity multiplied by F. F is formation resistivity factor, and you can expand the F to be RO divided by RW, where RO is resistivity of water saturated rock, whereas RW is formation water resistivity, all right? And then you can calculate this with this another form of equation, which is A, tortuosity factor multiplied by the porosity powered by 1 minus M, and the M is cementation factor, right? So it's a petrophysical equation, which is very useful and quite popular, right? So we are going to, do an exercise about this, and it's going to be very short and simple. So let's say we have porosity of 0.23, and then let's say tortuosity factor is 0.81, and then the particle diameter, let's say I'm going to do this. Maybe I can merge this, right? It's 0.02 millimeter, for example. I need to convert it to meter, right? But let's check another data that we have. Let's say cementation factor 2.15, 2.15, and we need to estimate the permeability, right? Of course, we can do this by using these two equations. But first, we need to calculate the particle diameter in meter, all right? Of course, it's this one multiplied by 1 to the power of minus 3. As simple as that. All right, and then for tortuosity, we are going to use this. Okay, so it's this right-hand side. Okay, so A, tortuosity factor multiplied by the porosity, 0.23. Okay, powered by 1, open parenthesis, 1 minus cementation factor. All right, so this is the value, 4.39. And then simply we can calculate the permeability with this. But be careful, this permeability is in meter squared. So I'm going to do this. Okay. Merge. Okay. This is MD and this is meter square. Superscript. All right, so it's this porosity powered by 3, or maybe open parenthesis first. Powered by 3 multiplied by dP squared. dP in meter squared. All right, and then all of them divided by 72 multiplied by the tortuosity factor, and then multiplied by, open parenthesis again, 1 minus porosity square, and close the parentheses. So this is the value, 2.6 e to the power of minus 14. All right, but it's in meter square. Okay, so now you just need to change from meter square to millidarcies. And the conversion unit is this. All right, so 1 square meter is this of millidarcies. So it's very simple. I just multiply this with 1.1 or 1.013 maybe to the power of 15. Okay, so it's in scientific, change it to general. All right, so this is, this is my permeability in millidarcies. All right, so it's very simple. Now we can estimate the permeability using the known data like porosity, particle diameter, all right, and then cementation factor, and with the use of Kozeny-Carmen correlation. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching, and see you again in the next Q&A videos. Thank you.